Hello again. In this video, I'm going to go over Objective 5 from Section R5, which is about applying a general strategy to factor polynomials. Now, in this section, we looked at several techniques to factor polynomials, and so we just want to develop a general strategy for factoring polynomials in this section. So the first step when you factor a polynomial, as I've mentioned several times, is to factor out the greatest common factor. So that's always the first step. And then the second step would be to look at the number of terms that you have. If you have 4 or more terms, then you want to try factoring by grouping. If you have 3 terms, you want to write the trinomial in the form of ax squared plus bx plus c, and then see if it is a perfect square trinomial. And if it is, you can either factor it into a plus b squared or a minus b squared. If it's not a perfect square trinomial, then you want to try to factor it using the trial and error method, or you can also use the AC method, which I talked about in a previous video. And if you have 2 terms, then you want to see if it falls into one of the 3 special cases for factoring binomials, which are the difference of squares, the sum of cubes, and the difference of cubes. Now remember, the sum of squares cannot be factored. Okay, so let's just look at some examples so we can practice this general strategy for factoring polynomials. Okay, so let's look at this one. So the first thing is to try to factor out the greatest common factor. In this case, the only thing that's in common is 1, so there's nothing to factor. But we do have 4 terms, so that's the next step, right? We have 4 terms, and so we might factor this by grouping. Let's try that. Okay, so the idea behind factoring by grouping is to group this into 2 pairs, and then factor out what each of the pairs has in common. And if it doesn't work, then you want to try a different arrangement. But for now, let's try these 2 pairs. We're going to pair these 2 up and factor out what they have in common, and then we'll pair these 2 up and factor out what they have in common. And if it doesn't work, then we'll rearrange this and try something else. Okay, so these have in common, these 2 have in common x cubed, right? Let's factor that out. Okay, so then you're left with x squared minus 9. And then these have an 8 in common, so let's factor out an 8. And then you're left with x squared minus 9. And so this is going to work because you have the same thing in the parentheses. That's how you know if your factoring by grouping is going to work. So then you can factor this out of both of these terms. So I'm going to factor out the x squared minus 9. And then when you yank this out of here, you're left with x cubed. And when you pull it out of here, you're just left with an 8. Okay, so that's what you get after you factor by grouping. But then notice you have a binomial here, and you want to check and see if it falls into one of the special cases that we have for factoring binomials, and in fact it does. It's the difference of squares. Okay, and you can see that A is the square root of x squared, which is just x, and the B is the square root of 9, which is 3. And so this is going to factor into x plus 3, x minus 3. Okay, but this is also a binomial, so you want to check again to see if it falls into one of the special cases, and it does. It's the sum of cubes. Okay, and so you can check here the cube root of x cubed is x, and so that's your A, and then your B would be the cube root of 8, which happens to be 2. And so this is going to factor into x plus 2, and then x squared minus x times 2, but I'm going to change the order. Again, the order in which you multiply doesn't matter, so I'm going to write that as 2 times x, and then plus b squared, right, where b is 2, so 2 squared. okay? And then 2 squared is just 4. So I'm just going to write that as 4. Okay, and then you want to check this last piece here. This is a trinomial. It has 3 terms. So you want to see if you can't factor this trinomial. Now this happens to be what I would call an easy trinomial because the leading coefficient is 1. And so in those cases, all we need to do is look at all the factors of 4 and find 2 factors of 4 that add up to the middle term, which is negative 2. So let's see if we can't find those. Okay, so you just can systematically go through this and just try. Let's see, 1 and 4 sums to 5. 2 and 2 would sum to 4. If you go to 3, 3 is not a factor of 4, so then you go to 4. So 4 times 1, which adds to 5. And of course, none of these are going to work because you need the middle term to be a negative. So then you go to the negatives, and negative 1 times negative 4 gives you negative 5. So that doesn't work. And then negative 2 times negative 2, that adds up to negative 4. So that doesn't work. And then you jump to 3. Of course, negative 3 is not a factor of this, but then negative 4 is. Negative 4 times negative 1 gives you 4, right? So these are 2 factors, but then that adds to negative 5. And so we have exhausted all the possible factors of 4. And then none of these sum up to negative 2. And so if that happens, then that means this trinomial does not factor. Okay, if you've exhausted all the possible factors here and none of them sum up to the middle term, then your trinomial does not factor. Okay, and we haven't talked about that a lot. Not every trinomial factors. Okay, and this happens to be a case where the trinomial does not factor. Okay, but you'll only know that if you exhaust every possible case over here. Okay, so make sure you've exhausted all possible factors and check their sum and make sure that none of them sum up to the middle term. Okay, and if you've exhausted all the possible factors and none of them sum up to the middle term, then the trinomial doesn't factor. Okay, so let's look at so this is the final factorization, right? This cannot be factored any further. Okay, so let's look at another example. Okay, so this one has 4 different terms in it. Okay, of course, the first thing we're going to do is factor out the greatest common factor, which happens to be 1, so there's nothing to factor out. And then it has 4 terms, so we're going to consider factoring by grouping. But it turns out that if you try to factor this by grouping, it doesn't work. None of the arrangements that you can create actually produce a situation in which factoring by grouping would work. But let me show you, there's a little bit of a trick for this one. Okay, it's kind of different, so this is kind of a unique case. What we're going to do here is we're going to factor out this negative from the last 3 terms of this polynomial. So I'm going to pull this minus sign out of all 3 of these terms. Okay, so if I do that, I'm left with x squared plus 4xy plus 4y squared. Basically, if I pull a minus sign out of each of these terms, then each of these are going to change sign, right? So they'll all become pluses. And then I'm going to focus in on this trinomial inside this parentheses. And we're going to try to factor that trinomial. And we're going to use the AC method to do this. Okay, so in the AC method, you multiply the first term by the last term. Okay, and so when you do that, you get 4x squared y squared changing the order of multiplication. And what you have to do is you have to look at two factors of 4x squared y squared. We're going to look at two factors of this that sum up to the middle term, which happens to be 4xy. Okay, and let's just go through this systematically. Now we do know that when we factor this, it's going to factor into xy and xy, but we just have to figure out what the coefficients in front will be. Okay, so we're going to look at all the possible combinations for two factors that multiply up to 4. Okay, so starting with 1 times 4. And then you add these together and you get 5xy. So that doesn't work because we want it to be 4xy. Okay, then you go to 2. Okay, so those are two factors of 4, but then when you add these together, you get 4xy. And that is the middle term, so this is what we need. Okay, so then remember what you do after that is you go back to your middle term, which is 4xy, and you write it as 2xy plus 2xy. Okay, so this middle term is the same as adding up these two terms. And what you're really doing is you're going back to the 4 terms that you get when you FOIL. So this is first, outer, inner, last. And what happens is we take the outer and the inner, and since these are like terms, we can add them up, and it would add up to 4xy. So what we have to do is we have to take this middle term and go back to the outer and inner that it came from. And the only way you'll know which one's the outer and which one's the inner, right, is to go back and find two factors that sum up to the middle term. Because this can be broken apart in several different ways. This could be, when you add them together, how do you know it's not 3xy plus xy? Okay, so we have to figure out what the outer and the inner are before they get added up to 4xy. Okay, and the only thing that's going to work is 2xy plus 2xy. Okay, so having said that, the next step is to factor this by grouping, right? You have 4 terms now, and we're going to factor it by grouping. Okay, so we're going to pair these two up and pull out what they have in common, and it looks like they have an x in common. So let's pull that x out. And of course, you're left with an x here, and then you're left with a 2y here. Okay, and then pair these up and see what they have in common. So it looks like they have a 2 in common, but they also have a y in common. So let's pull out that 2y. Okay, and then you're left with, for the first term, it looks like you're left with an x. And then for the second term, you're just left with a 2, but you're also left with a y. Because y squared, you have 2 y's here. One of them was pulled out, so that means you have 1 left over. Okay, and then notice that in the parentheses you have the same thing, and so factoring by grouping is going to work because now we can factor this out of both terms. So I'm going to pull this x plus 2y out of the first term, and that's going to leave us with an x, and then we can pull it out of the second term, and that'll leave us with this 2y. Okay, and so that's how it factors. So we just factored this trinomial. Okay, this trinomial factors into this, which we can write more compactly as x plus y squared. Remember, this means when you square something, it means multiply it by itself. Okay, so a more compact way of writing this is just to write it like this. But we're not done, because this happens to be the difference of squares. This piece over here, I think it's pretty evident that this is being squared, right? X plus 2y is being squared. So that's certainly a candidate for the b value, right? Okay. So remember the difference of squares, a squared minus b squared is equal to a plus b times a minus b. Okay, so let's try to identify what a and b are. So a is going to be the square root of this first term, which is 5. And then b will be the square root of the second term, which is just x plus 2y. And of course it is, because x plus 2y squared, right, will give you this. Okay, so that needs to be our b for sure. Okay, so let's see how this factors. A plus b, right? 5 plus this, right? This is a and this is b, so 5 plus this, a plus b. Okay, so that is a plus b times a minus b. A minus b. And I'm going to put this in parentheses because I'm subtracting all of b. And all of b is x plus 2y. So it has to be put in parentheses. Okay? So a plus b, a minus b. Okay? And so that's how it factors. Okay? And, I think we're done factoring this. You may want to consider distributing this minus sign. So we can do that. Okay? So this would become minus x and then minus 2y. Okay? And so that's how this factors. And if you want to check your answer, you could go through and multiply this out and make sure that it equals this. Now to do that, probably the most efficient way of doing this is to take this 5 and multiply it by all 3 terms, and then take the x and multiply it by all 3 terms, and then take the 2y and multiply it by all 3 terms. And you'll end up with 9 terms, and some of them will be like terms, and it will condense down to 4 terms. Okay, in fact, it will condense down to these 4 terms. Okay, so that's how this one factors. Okay, let's look at one more. Okay, so at first, we want to factor this. Okay, and at first, the first thing you want to do is factor out the greatest common factor. Okay, and you actually have 3 different terms here, and the only thing they have in common is a 1, so there's nothing to factor out. And now we're going to do something we've never done before. We're actually going to use substitution to make this easier to see how to factor. Okay. So this is kind of another special case. Okay. This is probably one of the more challenging cases that you would run into. Okay. So what we're going to do to make this a little bit easier to see is we're going to let u, I'm going to introduce a new variable. I'm going to call it u. And I'm going to let u be x squared minus 5. Okay, this is called substitution. I'm substituting u in for x squared minus 5. Okay, if I do that, this is u, right? I'm calling this u just to make this easier to see. Okay, if I do that, then this is going to become u squared. And I'm calling this u. So this is going to become 2 times u minus 24. Now, you can see why I'm doing this. By calling this u, right, x squared minus 5u, when I substitute that in for u, I end up with this trinomial in u, in terms of u. Okay, and now that it's a trinomial, I can focus in on just factoring this trinomial. Okay, and then when I'm done factoring the trinomial, I'll go back and substitute u back in. Okay, so this is one of the easy trinomials because this leading coefficient is 1. And so what we really just need to do here is look at all the factors of negative 24 that sum up to the middle term, which happens to be 2. Okay, and so let's just run through these. All right, 1 and 24. One of them has to be negative. Okay, that would add up to negative 23. 2 and 12, negative 12. Okay, and that would add up to negative 10. 3 and 8, or negative 8. So that would add up to negative 5. 4 and negative 6. That would add up to negative 2. Okay, so this is close, right? We want it to be positive 2 instead of negative 2, so then you might consider switching the signs or continue on systematically. Okay, so I'm just going to, you could go to 6 and then negative 4 systematically, right? Well, the next would be 5, right? But 5 is not a factor, so then next would be 6. Okay, so then you get 6 times negative 4, and then when you add these together, you do get positive 2. Okay, so these are the two we need. Okay, so this is going to factor into u plus 6 times u minus 6. And then we're going to go back and substitute back in for u. Okay, you don't want to leave your answer like this because the original problem didn't have a u in it. We just kind of arbitrarily gave a name for this x squared minus 5 and we called it u. We pulled this letter out of thin air. Okay, and so make sure that, and when we did that just to make it easier to factor this trinomial. Okay, and now that we've factored it, we of course have to go back and substitute what u is back into this trinomial. Okay, because our answer needs to be in terms of x, not u. Okay, u is just a stepping stone. Okay, that allowed us to factor this trinomial a little bit easier. Okay, so now that we're done factoring the trinomial, let's go back and substitute this back in for u. And so this is really x squared minus 5, right? Okay, just that piece. And then you're adding 6 to that. Okay, and now I got to substitute for this u. That's also x squared minus 5. And then you're subtracting 4 off of that. Okay? Okay, and so look what happens after you do that. Here you get x squared plus 1. And then here you get x squared minus 9. And now notice that this is the product of two binomials. Now this first binomial is the sum of squares. And remember, the sum of squares does not factor. So this does not factor. But this one does, because it's the difference of squares. Okay, and so let's factor that. Okay, so I'm going to put that down here. And let's just figure out what a and b are. So a would be the square root of x squared, which is x. And then b would be the square root of 9, which is 3. And so this is going to factor into a plus b, x plus 3, times a minus b, which would be x minus 3. Okay, and that's it. You can't factor this because it's a sum of squares, and these no longer factor. Okay. Okay, so that's how this factors. So this one's kind of challenging because you have to know to use substitution to do this. Okay. And again, the only reason we did substitution here, or we used substitution, was to make it easier to see that there's really a trinomial, a quadratic trinomial hidden in here, right? If I let this be u, this x squared minus 5, if I let it be u, then it makes it clear that this is a quadratic trinomial, which I can factor. But then again, but remember, after factoring it, I have to go back and substitute u back in, right? So don't forget to do that. Okay. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.